Hello and welcome to my class. I'm Grolin Annesley from ThinkMo Education. I'm currently a Cisco technology lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 5834444290. Today's topic is packet forwarding process, routing basics, and static routing. I left you a homework last class. Let everyone do an experiment of data forwarding across network segments. Before starting the lecture, let's first do a basic review of the content of the previous class. Let me explain to you from the data forwarding process. Let's look at this picture. Actually, it's similar to the lab assignment I gave you last class, except the address is different. Host A here have an address. Then the router side is the gateway of host A. The address of the right interface of the router is the gateway of host B. If future host A to send data to host B, this is equivalent to a data access across network segments. The data will be sent to the gateway first. But what we are discussing today is not ARP. Let's review the overall data forwarding process. For data, when we were in the first class, learned the overall encapsulation of the data. Data is sent from the sender to the receiver. When it is processing data between the two, what kind of relationship exists? Let's first look at the process of data forwarding. Let's start with 4 layers. The first lesson, OSI 7-layer reference model. Then the upper 3 layers refer to application layer, presentation layer, session layer. These 3 are combined into one big application layer for TCP/IP protocol stations. As a network worker, let's talk about the next 4 layers. The application layer now produces a data. Then you will first reach the 4th floor. That is transport layer. Encapsulate. In this picture, here you can see a data we send. A destination port number is identified here. When we talked about the model, I told you 4 layers have 2 protocols. One is TCP. The other is UDP. A destination port will be marked inside. Before we talk about this picture, I want to draw a picture. Okay. Let's talk about this in detail. When data is being sent, why exactly is it carrying a port number? For example, now there is a device on the left. This is a host. On the right there are multiple servers. We draw multiple servers here. Then go to multiple servers in the future for corresponding data access. Now here is a line. There are 3 lines here. Connect separately. This is just a simple schematic. Does not mean that the real network is like this. First make an address plan. Let's say this is 192.168.1.1. Different ports correspond to different applications. In fact, Cisco content designs overall curriculum. For the transport layer, very little is said in the NA stage. But I think if we don't talk more, you may not understand. So let me explain in detail. This is a PC on the left. On the right there are 3 servers. Suppose this is WeChat. This is YouTube. This is WhatsApp. Now I want to log into these 3 apps on this device at the same time, whether it is a mobile phone or a computer. That is, I want to access the 3 servers corresponding to them. So now I ask you a question. If the host now sends them a data, can this data reach the peer? We do not consider data forwarding across network segments today. And the problem of forwarding on the same network segment is based on address. Is this data available now? For example, now access 192.168.1.2 from 192.168.1.1. Data can be sent. That is, based on what we learned about IP addresses, to this position. There is actually no problem with the exchange of visits between addresses. Data can come. But we're going to see what is the process of sending data to the past. If you want to access WeChat from 192.168.1.1, just send a data to 192.168.1.2. If you want to visit YouTube, just send data to 192.168.1.3. Access WhatsApp words. Just send data to 192.168.1.4. This is not a problem. According to data communication, this data can definitely pass. Find the address of the server. Forwarding through routers in the middle. Just send it. But between the data, the principles of data communication we pay attention to. What is called data comes and goes. A sends a data to B. B has to reply a data to A. Just like the ping mentioned in the last lesson. An ICMP request message is sent. The peer needs to give a reply. It's called data communication. PC now access WeChat. It's looking at a certain data in it. The PC initiates a request to WeChat. WeChat needs to reply to the PC. Then when replying to the packet, there is going to be a problem. How to reply the packet? When replying to a packet, the order is like this. I write it out for you to see. We just change the position of it. The 3 destination IPs become the source IP. The 3 source IPs become the destination IP. When the data comes back, it looks like this. WeChat wants to reply to this device. YouTube has to give it a reply too. WhatsApp also has to reply to it. Now the data is back. But for the current device, it received data from 3 different places at the same time. They are all different servers. But they all return to this device. If the device has only one IP address as an identifier, then here comes the problem. How exactly does the device now find? Now what application does this data correspond to? For WeChat, the device initiates a data request. WeChat replied to it. No problem. That for the device. Received from 3 servers at the same time. Reply to its data. Then please. Is this data from WhatsApp or WeChat? Is this data from YouTube or WhatsApp? I can't say now WhatsApp to device data. Put it in WeChat for processing. So for 192.168.1.1, it is now time to differentiate and measure. How to distinguish different application services. Communication based on IP address now. It can only achieve host-to-host communication. That is, sending from one host to another host. Nothing more. That's on the host. I want to run multiple applications on one device. Implement multiple services. Application-to-application communication. It can't be achieved. Now relying solely on IP addresses. There is no way to handle it. We're going to use the transport layer to process. Then in this picture, the transport layer we wrote. It writes a destination port called 80. This is one of the port numbers that everyone is asked to memorize.